Today's lecture is, and the topic of today's lecture is OSI model and TCP IP model. Let's start with the first topic. OSI model. OSI stands for Open System Interconnection Model. It has been developed by ISO. ISO stands for International Standard Organization in the year of 1984. It is a 7-layer architecture with each layer having specific functionalities to perform. All these 7 layers work collaboratively to transmit the data from one person to the another across the globe. So what is OSI model? Basically, OSI model is used by both the sender as well as the receiver whenever they are going to be communicate. The architecture of the OSI model is it is consists of the 7 different layers. It has the 7 different layers. Every layer has their own functionalities, their own functions, and they are interlinked with each others. All the layers they can perform collaboratively to do the task. So next is, now this is the diagram from which it is very much clear to everyone that how the OSI model looks like. Let's start from the downwards. Look at your screens. The first layer is the physical layer. The first layer name is physical layer, then data link layer, then network layer. And the second name of these 3 layers are, you can also say, these are the hardware layers. First 3 layers, they also known as the hardware layers. Now the fourth one is the transport layer, and the second name of this transport layer is also known as the heart of OSI. The heart of OSI model, the name of this particular layer is transport layer. Now at the fifth, the session layer is there, and on the 6th position the presentation layer is there, and at the top and the last and the 7th layer of the OSI model is application layer. And these 3 layers, session, presentation, and application, these 3 layers also known as the software layers. As the name implies, the first they have the hardware layers, means they are going to deal with the hardware, and these are top 3 layers of are known as the software layers, so they are going to be deal with the softwares. So this is all about the architecture or the diagram of the OSI model. Now the first layer is physical layer. It is also known as the layer 1. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. The physical layer contains information in the form of bits. It is responsible for transmitting individual bits from one node to the next. When receiving data, this layer will get the signal received and convert it into the zeros and once and send them to the data link layer, which will put the frame back together. So this is all about the physical layer. First thing is, it is the first layer of OSI model. Second, this layer is responsible for the physical connection between the 2 different systems. The physical connection can be made at the physical layer. Third, it contains the information in the form of bits, either in the form of zeros and ones. All the data or all the information that contained by the physical layer, that should be in the form of bits, and it is responsible for transmitting the individual bits from one system to the other system, and these bits are in the form of zeros and ones. So whenever we are using the OSI model and we are in the receiving side, the layer will get the signals received and convert it into the zeros and one. Whenever suppose we are at the receiving side, we receive the signals and we can convert these signals in the form of bits, and these bits are known as zeros and ones. and this particular layer can combine all the bits in a single form. As shown in the diagram, look at the diagram given below. These 1100, these are the bits 0111 and 0011. So these are the number of bits, and the physical layer deal with the number of bits. So this is all about the physical layer. Now next are the functions of the physical layer. First, we have the different functions of physical layer. Let's start with the first one. The first is bit synchronization. The physical layer provides the synchronization of the bits by providing a clock. This clock controls both sender and receiver, thus providing the synchronization at the bit level. Now the first function is bit synchronization. The bit synchronization means it can control the flow of the bits, because we all know the data in the physical layer, they deal in the form of zeros and ones. They deal in the form of bits. And for the bit synchronization, they use the clock. What it means, the clock simply controls the sender as well as the receiver, and they're providing a synchronization at the bit level. So what will happen? We are going to apply the clock on both the sides, at on the sender side and on the receiver side. So every 1 second, the sender can send the data, and every 1 second, the receiver can receive the data. So what will happen? After the end of 10 seconds, the 10 bits can be sent by the sender, and the 10 bits can be received by the receiver. This is called bit synchronization, or you can say the number of bits that are sent at the same time is equal to the number of bits that are received by the receiver at the same time. Second, the bit rate control. The physical layer also defines the transmission rate, that is the number of bits sent per second. As mentioned in the first point, bit synchronization, if the synchronization is there, automatically you can control the bit rate. What is the bit rate? As we discussed earlier, suppose at the sender side, they send the single bit into a single second, and the receiver can receive the single bit at the same second. So what will happen at the end of the 10 seconds, sender can send the 10 bits and receiver can receive the 10 bits. So this is called bit rate control. It depends upon the sender to control the rate of the bits. Third, physical topologies. Physical layer specifies the way in which the different devices, nodes, systems, anything you can say, are arranged in a network, that is bus, star, or mesh. We discussed the number of topologies. We discussed the network topologies there. In the physical layer, it is the responsibility of the physical layer to decide the different architecture of the systems. What it means, to decide which particular topology we are going to use in a network. Fourth, transmission mode. Physical layer also defines the way in which the data can flow between the two connected devices. The various transmission modes possible are simplex, half duplex, full duplex. What it means, it can decide the transmission mode. Transmission means the communication mode, and we have the three different communication modes. The first one is simplex, second is half duplex, third is full duplex. So which mode is currently used in the communication, that is also decided by the physical layer. The second layer is data link layer. The data link layer is responsible for the node to node delivery of the message. The main function of this layer is to make sure data transfer is error free from one node to the another node over the physical layer. When a packet arrives in a network, it is the responsibility of the DLL, that is data link layer, to transmit it to the host. So what will happen? In the case of data link layer, basically the first responsibility of the data link layer is, this layer is responsible for node to node delivery of the message. Node to node, or you can say from system to system delivery of the message. The main function of this layer is to make sure that the data that is going to be transferred from the sender to the receiver, that data remains the error free. What it means, the no error should be there. It is the responsibility of data link layer. And at last, whenever a packet is arrived on the network, Whenever any packets are coming, packets means the combination of bits. In the case of physical layer, we have the number of bits are there. We can add that bits into a particular value, and that value is known as the frames. So look at your diagram, the frame is there. We have the different frames over there at your diagram. So it is the responsibility of the data link layer to transfer these particular packets from one system to the other system. This is all about the data link layer. And the functions of the data link layer are, it has the first function is the framing. Framing is a function of the data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching a special bit pattern to the beginning and the end of the frame. So the first responsibility is the framing. Framing means whenever we are going to add a number of bits, the combination of these bits are known as framing. So this particular layer, data link layer, can make a number of frames, and the data that can be sent by with the help of data link layer, that can be sent in the form of frames, and they are adding a special pattern with every frame. A special pattern means any special pattern. For example, we are using 110010. Suppose this is a special pattern. Why? We can add this particular pattern at the start of the frame and at the end of the frame. So what will happen? It can represent that the frame can start from this particular pattern and also end with this particular pattern. So this is called the framing. Second, the physical addressing. After creating frames, data link layer adds the physical addresses, or you can say the MAC addresses of a sender or the receiver in the header of the each frame. Whenever a frame is made, so data link layer can create the frames. The frames are ready. Then they can add the physical address, or you can say the MAC address of the sender as well as of the receiver. Suppose I am going to send some data towards you. What will be happen in the data link layer? They can add the physical address of my, because I am the sender, and also add the physical address of yours because you are the receiver. So this is called the physical addressing. The third one is error control. Data link layer provides a mechanism of error control in which it can detect and retransmit damaged or lost frames. So the third one is error control. What will happen in the case of error control? They can control the error in the data. If any error is there, they can detect the error and retransmit the damaged or the lost frames. Because why? Because the data that is sent from sender to the receiver, they send in the form of frames. Flow control. The data rate must be constant on both sides, else the data may get corrupted. Thus, the flow control coordinates that amount of data that can be sent before receiving acknowledgement. And what is the meaning of flow control? Means they can control the flow of data. And if they are going to control the flow of data, what will happen? The sending speed is equal to the receiving speed. Sending speed means in which speed we are sending the data, and receiving speed means in which speed the receiver can receive the data. This is called the flow control. Means to control the flow of data, or to control the flow of data or the flow of communication in between the sender and the receiver. And the next is access control. When a single communication channel is shared by multiple devices, MAC sublayer of the data link layer helps to determine which device has control over the channel at a given time. So access control means to give the access of that particular transmission media to a single device who wants to send the data. Let's discuss an example. Suppose we all are want to communicate with each other. Right now you all are on the mute. If anybody from your side who wants to speak something, I'm going to unmute that particular person. So what it means, at the same time only that particular student have the control of access of this particular transmission media to say anything, because the rest of the students, they all are the mute mode. So this is all about the access control. Now the third layer is the network layer. Network layer works for the transmission of data from one host to the other located in a different network. It also take care of the packet routing, that is the selection of the shortest path to transmit the packet from the number of routes available. The sender and receiver's IP address are placed in the header by the network layer. So what are the function of network layers are? The first thing that the network layer basically works for the transmission of data from a one system to the other system, but that other system is located in the different networks. What it means, now the network layer is responsible to communicate the data from one network to the other network. And the second and the main responsibility of the network layer is it also take care of the packet routing. Packet routing means to select the different route from sender to the receiver. We have, whenever suppose system A wants to send some data to the system B, there are the number of ways from which the system A connects with the system B. But it depends upon the routing algorithms to select a best route, or you can say to select a shortest path or the shortest route for the packets that can be followed by the packets, and the packets easily delivered to the receiver's side. And last, the sender and the receiver, they both have the IP addresses. These IP addresses can be added at the header by the network layer. Whenever the data is sent in the form of packets, the IP address of the sender as well as the receiver, they can be added on the header of each packet by the network layer. So this is all about the network layer. Now the functions of network layer. The first one is routing. The network layer protocols determines which route is suitable from source to destination. The function of the network layer is called routing. Routing means, as we discussed earlier, we suppose a system A wants to send the data to the system B. There are the number of paths are available. Number of paths are available means the number of routes are available. Now it depends upon the routing algorithms to select the best route, and this can be done by the network layer. Second, logical addressing. In order to identify each device on inter network uniquely, network layer defines an addressing schemes to detect. What it means, to detect each and every system that is present on the network. For this, they have the special addressing scheme. The sender and the receiver IP addresses are placed in the header by the network layer. Such address distinguish each device uniquely and universally. What it means, the simply the IP addresses of all the systems, they can be placed by the network layer. So we can easily detect with the help of IP addresses, we can easily detect the number of systems. Okay, the next is the transport layer. The transport layer provides services to the application layer and takes services from the network layer. It means they provide the services to the upper layer and they can receive the services from the down layer. The data in the transport layer is referred to as the segments. The data that is deal in the transport layer, they are known as the segments. It is responsible for the end-to-end delivery of the complete message. End-to-end delivery means from one system to the other system of the complete message. The transport layer also provides the acknowledgement of the successful data transmission and retransmit the data if an error is found. Now the main thing is, in the case of transport layer, we have the option of acknowledgement. What is the meaning of acknowledgement? Means whenever any packet or any segment that is received by the receiver side, they can send the acknowledgement of that. If the acknowledgement is received by the sender, then the sender comes to know that my packets are received by the receiver. So next they are trying to send some other packets, and if some acknowledgement of some packets that is not received, so simply they can retransmit these particular packets. And the services provided by the transport layer are the connection oriented services and the connection less services. So what is the difference between the connection oriented and connectionless is? Connection oriented means a particular connection is made between the sender and the receiver after the communication can be happened. And in the case of connectionless services, the no particular or the dedicated connection is made between the sender and the receiver, or they can directly send the message in between the two systems. So the functions of the transport layer are segmentation and reassembly. This layer accepts the message from the session layer, breaks the message into the smaller units. Each of the segment produce a header associated with it. The transport layer at the destination station reassemble the message. What it means, first they have the complete message. They can divide the message into the small parts. These small parts are known as the segments, and they can give the reference number to all the segments. Suppose I want to send the data towards your side, I can break the message into the 5 categories and give the reference number 1, 2, 3, 4, 5. You can receive all the 5 segments, but in a different manner. For example, first you receive the third packet, then fifth, then first, then second, then fourth. But the reference number is there, so you can easily reassemble all the message into the particular order. And the order is 1, 2, 3, 4, 5. So this is called segmentation and reassembly. Second is service point addressing. In order to deliver the message to the correct process, transport layer header includes a type of address that called the service point address or the port address. You can simply call the port address. Service point address is also known as the port address. Thus, by specifying this address, transport layer makes sure that the message is delivered to the correct process. With the help of this port address means, I just give you an example. Suppose we want to send the data from one system to the other system. We can write the IP addresses of system and also write the port number of process. So the so the data can be received by the particular process, particular system, and in that particular system, the data is received by the particular port. So this is called the service point addressing.